Good morning and welcome to this session. The session consists of a single talk on multilingual and crosslingual retrieval in digital libraries. The talk will be presented by Sudeshna Sarkar. Sudeshna Sarkar is a professor and currently the head of the Department of Computer Science and Engineering, IIT Kharagpur. She completed her BTech in 1989 from IIT Kharagpur, MS from University of California, Berkeley, and PhD from IIT Kharagpur in 1995. Her research interests include artificial intelligence, machine learning, and natural language processing. She has been working on the text mining and information retrieval systems and is very involved and an active researcher in developing natural language processing resources and tools for Bengali. She is also currently working on applications on machine learning in several domains such as climate science and retail. I'd request Professor Sarkar to take the stage and present.
Thank you, Professor Basu, for the kind introduction. So I'm very happy to talk about multilingual digital library. So multilinguality is a topic which is very close to my heart, and I take this opportunity to talk about multilinguality and to advocate more and more the use of technology to enable multilinguality in the platform of digital library. So, as a brief introduction, you know that there are many languages in the world. So about 7,000 are very active languages. And India is a multilingual country having more than 120 large languages, of which there are 22 official languages. And we have also multiple dialects of the language. So India is a country where there are many languages which are used by different people in different geographical regions. And however, a large amount of literacy and higher education takes place in English, and a section of the people, they use English most comfortably as the medium of education, communication, and the use of the web. And the use of other languages is underrepresented, even though these languages are spoken by a very large number of people compared to the world population. However, 80% of the people in India are not language literate, and multilinguality is the way to go forward to break the digital divide and provide universal access to different people. The theme of multilinguality is also very much in line with the vision or with the mission of UNESCO, who advocate the promotion and use of multilingualism, the promotion of linguistic and cultural diversity, and promoting universal access to cyberspace. However, in the cyberspace, languages are not equally represented. The power of the different languages is affected by their presence in the cyberspace, as that is one of the most important medium of people to communicate and interact with each other. So the universal digital library that we envisage should ideally bridge this gap and let users find objects in languages which are different from the language that they are familiar with, and in any language that they desire. And the motto of NDL is inclusivity, as Professor Das and Professor Chakraborty has explained yesterday. The motto of NDL is to reach every Indian, and we cannot reach every Indian if we do not have multilingual enablement in the National Digital Library. Now, with respect to a digital library, language has different roles. So these are the three different roles, places where language plays a role in a digital library. First of all, language associated with the data. And there are two types of data which is important in a digital library. One is the metadata, or information about the data, and secondly, the data about the content. Secondly, we have to think about the language of interactions, that is, such as the language in which the query is formulated and the system interacts with the user. Thirdly, the language of the interface. So in this talk, I will mainly confine myself to the first two roles of language, because there are other talks in this conference or this workshop where people will talk about the third issue. A multilingual digital library is a digital library that has all the functions of a library implemented simultaneously in as many languages as desired, and search and retrieve functionality are language independent, which means that different roles of language, the three roles of language that we talked about, all these roles are available in all languages. So before I start with the technical part, let me just tell you what we are going to talk about. There are three different aspects associated with the digital library. One is cross-language information retrieval. What it means is that the query that the user formulates can be in a language with which the user is familiar, and with that query, the user may desire to retrieve a document in another specified language which is different from the language of the query. The second is multilingual information retrieval, where the query is in one language and the results can be in multiple languages depending on which language the content is available. Of course, it has to be presented in a suitable way to the user. The third aspect, which is very important, is the question of access. So retrieval is not all. If I give a query in Bengali and retrieve a document in Marathi, that document may not be accessible to me if I am not familiar with that language. So there has to be technology which makes documents or content or data in other languages accessible to me so that I can make use of that document. So retrieval and access are the two main important components that we will talk about in this talk. Now, we will look at the different language technologies that are required for these two functionalities in a digital library. First of all, as a particular language is associated, sometimes more than one language is associated with the data, one has to be able to, in a digital library, one must identify the content with the data associated with the content. And this can be enabled through language tags, which can be given by the author or the curator, or through an automatic process. Secondly, the metadata has also a data associated with it, and there are certain fields of metadata which can be kept in a language independent manner, and those fields of metadata which use controlled vocabulary, they can be kept in a language independent manner and can be rendered in a language of interest to the user. Other fields of metadata have to be suitably presented through use of technology so that it is accessible to different users. Then we come to the content. So the content or certain parts of the content, in order to make it accessible, one will require access to technologies of machine translation. Now, in order to enable effective user interaction in a digital library, one must enable querying in different languages. And in order to do that, the system might help assist in query formation, query expansion, query selection, and also accepting feedback from the user when documents or results are presented to the user, and also may assist the user in browsing and translation where required. So with this brief introduction, I come to the second part of the talk, where we will talk about language technologies which enable a multilingual digital library. First, we'll look at the very basic things which are part of pre-processing very quickly. When we deal with languages, there are issues of normalization and spelling variation. These are some examples from Hindi and Bengali. We did not go through it. There are issues of stemming and lemmatization in order to have the right type of indexable item. When we are talking about cross-lingual digital library, cross-lingual information retrieval or multilingual information retrieval, stemming is not a very appropriate technology because when it involves translation, doing morphological analysis or lemmatization is more useful. Then there are things like tokenization, script rendering, etc. However, I will not spend time on this. Rather, I will focus in my talk on these aspects: indexing, query formation, retrieval, and ranking, and what is the role language plays in this. So, we want to discuss whether multilingual digital library is a reality or can be a reality in the near future. So what we see in the last decade, and especially in the last few years, natural language processing has made huge strides. And very high quality tools have been developed which have pushed the accuracy of different NLP systems, including many important NLP systems. Also, we see that there is a tremendous growth in data and resources in the last few years. However, the divide still persists. There are resource-rich languages and resource-poor languages, and in the age of the internet, the division between the languages have only got amplified. So there are few languages where there are a lot of resources, English being the primary candidate, and few other languages, and there are also a lot of annotated resources. Whereas for the other languages, there is either zero or very little resource, and it is very difficult to create annotated resources to take advantage of the technology, technology tools and methods that have advanced. For example, machine translation plays a key role in making access possible to users in different languages. So machine translation has made huge strides in recent years. However, the growth in the machine translation, high quality machine translation, is still restricted to at sentence level. So still now there is no good resource level machine translation, and also it does not work well for all vertical domains, especially in several technical domains. Now, as we all know, that neural network has played a very large role in the popularity of AI and machine learning and making many tasks possible in recent years. And NLP is a domain which has been greatly benefited and transformed by neural network technology. And neural network processing has been used for different tasks in machine learning, a few of which I mention here, which are important to us, such as entity and relation finding, in machine translation, in entity linking, and various such tasks. However, apart from the use of neural networks in natural language processing as a whole, the new growth in neural network has a lot of implications for multilingual technology. For example, there's a lot of work that I will talk about in transfer learning, where one can transfer methods from resource-rich language, where there is a lot of data, to languages where there is little or no data. And a lot of it, at the root of all of this, lies a shared representation of words, which I will talk about in a little bit of detail, and bilingual and multilingual resources that people have built up. Now, as I told, we'll talk about these two different dimensions, which are very important for retrieval and access, are the most important dimensions for making a multilingual digital library a reality. So what does retrieval entail? We need to index objects of the digital library in multiple languages. We need to enable access or retrieval through query in any language. The challenges inherent in this are dictionary coverage, out of vocabulary words, since all words may not be in the dictionary, and also challenges inherent to natural language, which is synonymy and polysemy, a word having several meanings and several words having similar meanings. And a solution which takes care of some of these is language-independent indexing, which we will talk about. The second dimension which is important to us is access. And in order to enable access, one needs to look at what is the stage that machine translation has reached in order to make access a reality. So with this, I will talk very briefly about representation, which has transformed the field of natural language processing in general, and multilinguality or cross-linguality has been greatly affected. We will see how this is greatly affected by this change and how it enables development in resource-poor languages. So, words, the traditional representation of words at individual entities fails to look at relationship between words. Words which have similar meaning, if they are treated differently, it has a lot of implications in retrieval. So the word representation, which has been going on for some years, but one of the seminal works which gave rise to a very simple representation of work came by Mikolov in 2013. The simple word vectors, where words are represented as dense vectors in the continuous space. So this representation, even though people have been looking at distributed representation and different algebraic methods, these simple methods and then the availability of pre-trained word embedding from Google, and also very easy to use systems to train word representations made a revolution in natural language processing. And there are, I'll not go into those details. There are simple methods of, simple and very fast methods of going through corpus or texts, monolingual text. You see, in machine learning, there is a lot of importance paid to annotated data. And annotated data is very difficult to find. However, unannotated data is plentiful. So, task-independent, universal word representation and being able to pre-train it and use them for different tasks has something which has had a revolution in natural language processing. And this type of simple representation is able to capture the regularity and relationship between words. And then, based on this, one can now think of representing words belonging to different languages in a shared vector space, where words which have similar meaning, irrespective of the language, will be together in the same vector space. And we will see what are the implications in information retrieval and information access. So the advantage of this type of shared representations are many. They benefit transfer learning, so that one can transfer different NLP tools from one language to another, and specifically from resource-rich languages to resource-poor languages. And this has a special implication for cross-language information retrieval or multi-language information retrieval, and we'll talk briefly about one or two such methods. It has been used in machine translation. And also, in machine translation is a statistical process which has been done through different statistical methodologies, and also recently by neural networks. And machine translation requires availability of parallel data in two languages. Again, such parallel data are not available in most pairs of world's languages. And this technology also enables creation of parallel corpus. So there are different types of resources. So in order to learn multilingual word embedding, again, one requires data. Now, people have developed different systems which work with different types of data. And some of these data are easy to acquire, some are more difficult to acquire. The most sophisticated type of data and most difficult to acquire are data where you have parallel sentences which are word aligned. You have parallel sentences in two languages and the words are aligned. When that is not available, you can work with data which is just sentence aligned. The third type of resources are dictionaries, bilingual dictionaries where you have mappings from one word to another. And the fourth type of resources is document aligned corpora, where you just have documents which are on the same topic or talk about the same entity. They are aligned at the document level but not aligned at the sentence level. An example is Wikipedia in two languages which share pages on the same topic. So these are examples of document aligned corpora. And if you go from the top to the bottom, these are most sophisticated types of data, and these are the data which are least sophisticated. And there are methods which can develop multilingual word embedding in all these scenarios. So I will just briefly tell the names of the methods here. So monolingual mapping means suppose you have two languages, you train the word vectors of the languages independently, and then we find a mapping to map the vectors of one language to the vector space of the other language. And this mapping can be done through simple linear transformation or use of canonical correlation analysis, or some such methods have been used. Then there are pseudo-crosslingual methods which train on pseudo-crosslingual corpus. But a pseudo-crosslingual corpus means it comprises of documents so that each document can contain words of different languages. And one such work I can tell you is that they take this Wikipedia document, a topic-aligned Wikipedia corpus, and they merge documents belonging to multiple languages, they shuffle the words and use that to train the word vector. And such methods have been effective for information retrieval tasks. Then cross-lingual training on parallel corpus on joint objective, with the objective of jointly optimizing the monolingual similarity and the cross-lingual similarity, then joint optimization. So several methods have been used for multilingual word embedding. And we see some examples of learning from parallel corpora, and some work that we had done, and some examples which were used for cross-lingual information retrieval. Then this this slide depicts linear projection, canonical correlation analysis. Will not go into the details of this work. It's very slow. This is not changing. Okay. No, okay. No, I made 3 changes that didn't go through. Okay. So I said that there are different types of parallel resources. There's a recent paper which has shown that how easy it is to make multilingual word mapping. In this work by Atekse et al., they have shown that they have started with a dictionary. They have used a dictionary of 25 words, bilingual dictionary. And with that, they're able to achieve good accuracy in a shared multilingual, bilingual representation. So earlier work had used a few thousand, dictionary of few thousand words, and they have shown that even with 25 words, a 25-word dictionary is very easy to create, and they have shown that even with that, they get a very good multilingual word representation. So this is an example with document-aligned Wikipedia corpus and some sample results that we got. Now we will talk about, so we have seen that multilingual word embeddings are easy to achieve. If you see, word embeddings, there are very many methods of word embedding. I have only talked about Mikolov's method, but there are many methods which take into account the syntactic, semantic, and different other types of neighborhood in order to make the word embedding. And in order to get good word embedding, it is very important to have a large corpus. For example, Google's embeddings have been trained on the huge Google corpus. And they are able to, because they have been trained on such a large corpus, they are able to work on different tasks. However, when you go to a resource-poor language, such a large corpus may not be available to you. But multilingual word embedding enable us to use very little amount of bilingual data and get the vectors of your language in the same space of another language which has large amount of resources. And so this makes the creation of multilingual word vectors quite simple and has a role in bridging the divide between resource-rich and resource-poor languages. Now I will very briefly talk about certain methods by which these word embeddings or multilingual word embeddings can be used to enable information retrieval. So there are several types of methods. I will just briefly talk about some of them. The first type of method uses the standard TF-IDF sort of model for information retrieval and uses word embeddings to learn those parameters. I'm not talking about it here. The second type of method is to expand queries using these multilingual word vectors. Query expansion plays a very important role where the queries are ambiguous or not completely specified or partially specified. And query expansion plays a role here. And query expansion plays a very important role in cross-language information retrieval. In cross-language information retrieval, the standard method is to take the query in one language, in the source language, and translate it to the target language and use it for retrieval of documents in the target language. However, when the dictionaries have low coverage, or you deal with named entities or words that are not in the dictionary, or because ambiguities of different senses, such methods do not work well often in cross-language information retrieval. But word embeddings bring together words of similar meaning close to each other in the vector space, and they can be used for query expansion both in the monolingual case, and its effect is most important in the cross-lingual information retrieval domain. Second is information retrieval models that work directly in the embedding space, where both the documents and the vectors are mapped to a vector space, and in that vector space, the similarity and retrieval take place. Now, in order to do information retrieval, one needs data. And there are two types of supervised data which IR systems make use of. One is explicit relevance judgment, and second is implicit user behavior through click-through data. Again, when you think about data, there is a divide between resource-rich and resource-poor languages, or systems, or even systems where such data is not available. Again, putting words in a similar vector space help resource-poor languages to piggyback on the capabilities of resource-rich languages. So these are some examples of applications of word vectors to multilingual IR. Again, I will not go into the details. I'll just briefly talk about a method where we worked with word vectors, multilingual word vectors, and constructed a graph and used the clusters or communities in these graphs for query expansion. And one of the important findings that we found is that when our task was cross-language information retrieval from Hindi to English, we found that if we make the word vectors, if you only use multilingual word vectors having Hindi and English, we had a certain type of result. But when we expanded the multilingual word vectors to include other languages which were not relevant to the task, for example, we included Bengali and Marathi along with Hindi and English in the multilingual space, we found that the effectiveness of cross-language information retrieval improved. And our intuition is that when we use more and more languages, the individual word clusters become more well-defined and dense subclusters, which give rise to more effective community finding or cluster finding, which can enable better information retrieval. So multilinguality is not just helping cross-lingual or multilingual retrieval, it also helps in monolingual retrieval. So, now, secondly, as I said, the second type of method use embeddings of documents. Now, there are different types of methods which have been useful, found to be useful for short documents and for long documents. A very naive method, for example, would take the vectors of the words in the document and then take a sum or average in order to construct the vector of a document. And this works somewhat for short documents, but does not work very well for long documents. A lot of work has been done. I'll describe very briefly one such work on deep structured semantic model, which is also called deep semantic similarity model, which can work with large documents also, which also try to represent the query and document in the same continuous semantic space. And then it can model semantic similarity between the query and the document using cosine similarity. And this is a brief, just a picture of the architecture where you take the initial words, take the word vectors and do some hashing and then different layers of neural networks. And then you try to find out whether the document and the query match. Thirdly, I will talk a very little about use of knowledge graphs in information retrieval. Knowledge graphs are very important for monolingual retrieval, even for monolingual retrieval when the queries are ambiguous and not well specified. So knowledge graphs contain information about entities, attributes, properties, and their relationships. And there are many different knowledge graphs which have been created by AI researchers starting from several decades ago. And some of the ones which are popular now are DBpedia, Freebase, Yago, ConceptNet, the knowledge graphs of Google and Microsoft, etc. And these graphs can be used for relevance computation. So one can learn embeddings on the graph, and by trying to find out the importance of the different nodes and the edges, one can propagate the importance and use, and they have been very effectively used for information retrieval. But what I want to tell you today is that the availability of different multilingual resources like Wikidictionary, Babel, multi-word.net, word and multilingual word embeddings, along with this knowledge graphs, have made it easy. If you start with a knowledge graph, you can construct more easily multilingual knowledge graphs. And again, this is an instance where multilingual retrieval can piggyback on the success of monolingual retrieval and these resources that you have for resource-rich languages and build up effective ways of cross-lingual and multilingual retrieval. And then I come to the next topic, which is access. So retrieval is about retrieving documents which are relevant to your query in whatever language the document or content is present in. But a user may not understand those content unless they are presented to the user in the language which the user understands. So this brings one of the questions of access. There are other dimensions of access, some of which we'll talk about in other lectures today. So the type of access we are talking about is language access, which involves translation from language of object to the desired language. And machine translation is the way to go. Machine translation has made a lot of strides in recent years, but there are still shortcomings. I've already talked about there's no good progress in discourse level translation. They may not work on specific domain verticals. And those pairs of languages for which you do not have parallel sentences, they are at a disadvantage. So this was the scenario a few years back, and then came neural machine translation. So people started, just like any other topic, people started using neural networks for machine translation, which gave rise to good machine translation system, which reached state of the art and sometimes beyond. But what is more important to us, that neural machine translation means that it makes multilingual translation more of a reality and much easier than it was possible by the other statistical machine translation methods. So this is the basic model of neural machine translation. You have an encoder, you have a decoder. The encoder reads the sentence in the source language and captures it in a vector. And from that vector, the decoder decodes the sentence in the target language. And then, so the more sophisticated models using attentions and then multiple layers and different other types of things. So we have neural network machine translation systems. And then, so we'll talk a little bit more about that. And so one of the fallouts of this type of architecture for machine translation is that the sentences can now, at the end of the encoder, we have the sentences which are represented by vectors in some space. And so earlier we have seen words as a vector. We can have sentences as a vector. And sentences as a vector means we can compute similarity between sentences. And those sentences can be from different languages. Okay, so this is very slow. But yeah, so this is just an example. So these are different sentences, and they are also mapped to a same vector space so that the similar sentences are there in the same space. And these sentences can be in multiple languages. So these two papers are So there have been two very important papers. So the work was done in 2016. Both of these papers were in archive in 2016, and the papers got published in the journals in 2017, which talk about multilingual machine translation. So one is by the Google neural network-based machine translation system, which went live on the Google system in 2016, and the other is the system by Firath, Cho, Bengio, and others, multi-way multilingual neural machine translation. And we will just briefly talk about, will not go into the nitty-gritties of the architecture, but overall they have very similar approaches. This is a source language, and this is a target language, and they have several layers of different types of neural networks, and the encoder, and the attention model, and then a decoder. Now, so one of the things that this multilingual machine translation system showed is that the same model, the same box, can be used for translating between different language pairs. In the early days of machine translation, or even in the recent days of machine translation, we have those people who have worked on AI and machine translation. We have seen this Vokua diagram, which told us that if we want to go from language 1 to language 2, and if we want to do it for any n languages, there are two ways of doing it. One is to have NC2 or n square different translator systems, bilingual translation systems, and the second way is to go through interlingua. But interlingua was not a reality because people did not come up with good ways of classical semantic representation of sentences. But these multilingual and even multitask systems have shown that they can have a single neural network architecture which can take a sentence in any source language in the collection and get sentences for any target language using the same architecture, which is one of the concepts of interlingua. And if you do that, the number of parameters only grow linearly with respect to the number of languages and not quadratically. The added advantage that is of interest to us is that these pairs of languages may be differently resourced. There may be languages for which we have very little data, and especially there can be a pair of language for which we have very little or maybe no data, but we have data about some other pairs. And So these two papers have shown that by building this multilingual machine translation system, you can also enable something which is called zero-shot translation. So if you have some pairs from which you train, you can now, suppose in the training you did not have Japanese-Korean, a single parallel sentences in Japanese and Korean, and this system is still able to find translations in those languages with no data enabling them. And this has a very good message for people who want to advocate for multilinguality. So we have one model to learn them all, and it can work not only for machine translation, same model can be used for different tasks, image to text, text to image, text to syntax, and so on. So you can have a multimodal, multi-way, multilingual systems which can go from different languages and different boards by using a shared representation. So this picture in the Google paper is very educative. These dots that you see are the representations of different sentences. If you take this particular circle and blow it up, these sentences are all close translations of the same sentence. The stratosphere extends from about 10 kilometers to about 50 kilometers in altitude. All the sentences here belong to different languages and have similar meaning. And this same set of points have been color-coded here by their languages. And we see that the orange sentences belong to the same language. They are monolingual translations of each other, blue to another language, red to another language. And again, as I said, that there is a large-scale effort which is taking place to take different sentences on the web and map it to the same vector space. So a lot of exciting work is going on, and there are a lot of exciting implications from multilinguality. With this, I will stop, and if you permit me 1 minute, I will say the way forward is for multilingual digital libraries should enable universal access, and for this we need high quality, high coverage, robust language technologies for translation, text mining, interfaces for different languages. And we have to overcome the scarcity of resources in different languages and pay attention to creating different resources. And also, so it is important in order to take advantage of the language technology, it is very important to create resources and annotated resources in the languages that we care about, and then take advantage of the fantastic development that has been taking place in neural network and natural language processing. With this, I stop. Thank you very much.
If there are some questions we have got time for, 2 or 3. Yes.
Morning, ma'am. Thanks for an excellent theoretical foundation on cross-lingual information retrieval. I have 2 specific questions. So you said the most important part of this, cross-lingual information retrieval, when we come to the NDL or any digital information retrieval system, we need to have a multilingual dictionary kind of thing, which we technically call polyglot in library science. But my question is that, suppose I am giving a query in Bengali, say Krishi.
Right.
So it will take the equivalent one from Bhojpuri Kheti or equivalent English agriculture. So this translation will be on the fly, or there will be a predefined multilingual dictionary, built
So
up.
what I said is about work that is going on. So people have shown that it is easy to put words with similar meanings across languages in the same vector space. And in that vector space, given your query word, you can find words in different languages which have similar meaning to that word. Right?
Yes.
And, and that can be translated into platforms which are able to do it. There are technologies which enable us to do it fast, through the creation of one of the ways that we worked on is for creation of clusters, etc. So it is possible to quickly get the translations or get the similar words in different languages.
In real time.
In real, it should be made possible. Yeah, the technology is there which can enable it.
And my second question is that suppose in plural resolution, say in case of English, when I search catalog, it automatically takes IES or ES.
Right.
So
Those are the questions of stemming or lemmatization that I just briefly mentioned in the beginning. So one can have simple technologies like finite state machines in computer science, with which we can do this sort of stemming. And also a lot of work can be done when you have a large amount of data. This stemming can be obtained, or similar words with different forms. Even if you do not do stemming, you can bring together in close to each other in the same vector space. In fact, one good thing about the Mikolov's one reason why this type of word vectors became very popular, they found that if we get, if you get two words, suppose you say king and kings, and you say box and boxes. If you take the vector of kings minus the vector of king, you take the vector of boxes minus the vector of box, they give the same result.
But in case of Indic script, the plural resolution technique is so different from language to language.
Right. It is different, but it is possible. So we have worked with some Indian languages, the North Indian languages I have personally worked on. It is possible to build finite state transducers to take care of that, and one can do it. But there are also unsupervised technologies like Professor Mandar Mitro, Jia. They've been working on different technologies for stemming, which one can do automatically. So there have been a lot of technology which is suitable for stemming, using hand-coded rules, also using the data, and more is possible through word vectors and others.
I'll go to the next question. Yes, please.
Thank you, Dr. Sarkar, for an excellent presentation. This is to pick up, it's really a comment rather than a question, and it's to pick up slightly on the last question. One of my responsibilities is currently the chair of the International UDC Forum. I don't know if colleagues in the room know about UDC. I always describe it as not being DDC. So it's used in those parts of the world that do not traditionally have not used DUI, mainly the Soviet bloc, but also Spain, South America, and certainly most of East Europe, and to some extent China, and to some extent India as well. My comment really is just to make the point that UDC is available in over 50 languages now. There is a Bengali edition of it. There's a Hindi edition of it in preparation. I'm also told that there are summary editions in 6 other Indian languages. And we're very keen to work with India on collaboration and any opportunities that we can bring to these kind of problems. I would quote, and one good example of the way in which UDC has been deployed is the National Library of Switzerland, which has a similar problem that it has. I think it's 5 or 6 national languages, and it's developed the National Library Portal to be able to switch between any of those languages using UDC as the mechanism for switching, so that each of the languages is mapped to the other, essentially, and the whole is mapped backwards to DDC. You can't actually map the other way because UDC is much more finely grained than DDC. But it does give you that opportunity to essentially search in one language and retrieve in the other, and that is practically being done. So again, if there is any interest from the National Digital Library, or indeed any other colleagues in the room, about working with us, we'd be very pleased to see that. Particularly as UDC is essentially now crowdsourced. That's the way we approach things, and we do seek collaborators and people who are prepared to work with us on new and extensive editions. So thank you very much for that.
And thank you, I think, for the metadata and the translation and many other things. This will be very helpful for...
I can just allow one more question, the last one.
Excuse me. Regarding, you've been telling about machine translation. Is it been telling that it is real time and has been almost 100% correct? How do you relate it with the literature kind of a conversation? Do you feel it is perfect?
So I can tell you it is real time.
Yeah.
It is not 100% correct,
Yeah.
but its quality has improved tremendously in recent years,
In case of
especially
literature,
for different language pairs, for certain commercial translators, which we have seen available for people to use.
Right. So does it make the same kind of accuracy in case of literature, or because they are all figurative kind of things which have been used in different languages, and
Right,
the word does not mean exactly the word they are meant for, isn't
See,
it?
language is a very difficult subject.
True.
It's also, even all of us cannot understand all sentences.
Yeah, to some extent,
We cannot
yeah.
expect that the
Machine
machine can
can.
also understand.
So-
Maybe in some cases they can understand better than us.
Yeah, it does have
So
some
there is
limitations.
always an improvement possible. But what we have seen for different language pairs, machine translation has met a reasonable amount of improvement for certain language pairs and good at the sentence level.
Thank you.
Thank you very much, Professor Sarkar, for the excellent talk and the exposition. It's my privilege to present you with a memento.
And it's my privilege to share the stage with my co-supervisors. So I thank Professor Basu to chair the session, and I'll request Professor Sudeshna Sarkar to present a memento. Thank you.